Let's have a look at this question now. Valid Sudoku. So it basically asks you to either return true or false. True if the Sudoku is valid, and false otherwise. So what are the rules of it? So every row will have every element from 1 to 9, and every column will have every element from 1 to 9. And every small square, that 3 by 3 square, should also have each value from 1 to 9. If any of this condition is violated, then our Sudoku is not valid. For example, if let's say a number 1 is repeating in a row, or another number is repeating in a column, or another number is repeating in the inner square, then we say that our Sudoku is not valid. So let's start solving it. So what can be the brute force approach of it? Brute force approach can be to check for every number which exists. We should check if that number is repeating in a row, in a column, or in the inner square. If it is repeating, then we immediately return false. If not, then we return true. And we do this for every element. So without further ado, let's start coding. So we need to traverse in our matrix, and we are given that the board is 9 cross 9. So let's represent the row with I index and the column with j index. So, and as you can see, it's a vector and vector of char. So now another thing to note here is that the Sudoku is partially filled, and we just need to check whether it's valid or not. We don't need to check whether it is solvable or not. And we will only check on the filled values, not the empty cells. So our first condition will be pretty simple. If my board of ij is not equal to empty, that means if it has some value, then I basically write my code here. So, and then from here onwards, I'll just add a function if check of, let's name it check, ij board itself and the value. What will be the value? Value is basically the number. So if this check is returning me false, then I return false here, else I return true. Now let's write this check function, but before that let's have a value which is nothing but my board of ij, and I'll do a -0 to represent it in integer. Alright, so let's write the board, the check function. It will be of type boolean, and for ij, let's say it is r row and column. Board we have to pass by reference, and next thing is the value itself. Alright, so as I said, for each value we will be doing checks. The checks can be firstly the row check. So for row check, what can be, we basically need to traverse that row, right? So we need to traverse a single row. So for that single row, the row will remain same, only the column would go from 0 to 9, right? And we need to check if my board of ij minus of 0 is equal to my val. And one more condition, the row should be different. The column shouldn't be the same. So j should not be equal to the call which I am passing here, because we know that value will be same. So if this is the case, we straight on return false. Similarly, we will write the column check. So for column check, every column will be same, so only the row will be deviating. So we need to check a particular column for every row. So same thing, it will be j here, but instead of j we will write call, and here it will be I, and here it will be row, and instead of I this will be, instead of j it will be I, and row instead of column. So if that is the case, we do it. Now comes a slightly tricky part, that would be to check the inner square. So inner square are basically the 3 by 3 square. So before this we need to find, so there will be 9 squares in a Sudoku. So these 9s we need to check which square are we looking for. So every square will have a starting point of either 0, 0, 0, 3, 0, 6, 3, 0, 3, 3, 3, 6, and so on. So you get the idea. So let's say that an element, let's look at this 9 here. Let's look at the second square's 9 here. So the index in the whole Sudoku, in the whole board, is 1, 5. 1 is the row and 5 is the column. 1, 4. Yeah, 1, 4. So this is a part of second square. So how do we know it's a part of second square? So we write something like starting row, that will be equal to my row divided by 3 times 3. Similarly, for my column, it will be col divided by 3 multiplied by my 3. So, and now we know that the size of the inner square is basically a 3 by 3 matrix. So we can write something like, if I from I is equals to 0 to I is equals to 3, I plus plus, and for column it will be j is equals to 0, j less than 3, j plus plus, and then we basically we add our, so the row to check, so it will be I new will be nothing but my starting row plus I, and my j new will be nothing but my starting column plus j. Now we need to apply the same condition. If my board of I, j minus 0 is equal to the val, and my this new index I new is not equal to my row, or j new is not equal to my call. If that is the case, we return false. If no condition was returned false, then we return true here. Alright, let's run this and check if it passes or not. Okay, we are getting a wrong answer. Let's see if we wrote the code correctly or not. Okay, we are writing 9 by 9 matrix. Ij is not equal. Then we go inside this. The val is basically this number. And my check is ij, board and val. I and j is row call, board and val. Okay, if this check returns false, we return false. And what answer are we getting? We are getting false, but a true was expected from us. Okay, row check is basically j is equals to 0. Okay, j is not equal to column. This looks correct. This looks correct. Maybe we have done some mistake in our inner square. Okay, if we look at this example 9, for 9 the starting row would be 0 as expected and the starting column will be 3 as expected. So from 0 comma 3, so new I is basically 0 plus 0, which is this. New column is 3 plus 0, which is this. And then okay, this is correct, I think. Now board of ij. Oh, okay. It shouldn't be ij. It should be ri new and j new. Now let's run and check. Okay, we are getting. Let's submit and see if it passes. And it passes. Okay, so what will be the time complexity of this solution? So it's basically a 9 cross 9 matrix, and then for each in our check function we are doing 9 here, 9 here, and 9 here. So it's basically a time complexity for this solution is big O of 9 cross 9 and then cross for each. It's 9 plus 9 plus 9 here. This is the time complexity. And what is the space complexity? We are not using anything extra, so the space complexity is constant. Now, can we optimize this solution? Think about it. I mean, it's the same idea, but can we optimize it? So at one particular value, we need to check if in that row that same value is repeating or not, if in that column that same value is repeating, and in that inner square. So why not, what if we have something as some sort of data structures which will keep track of whatever we have visited, so that if again we get that value in that same row, we can just see and return false from there. So best data structure would be set in that case. So I will have vector of set for my row check, which will be of size 9, and similarly a column check and a square check. Okay, so so basically it's a vector of set. So I know that if I encounter a value which is not equal to 0, what I do here is nothing but I check if this value already existed in my either of row check, column check, or square check. So if row check of what is this value, row check of val is